When the demand during lead time follows a continuous distribution, calculations are a bit different. Here, to calculate the expected number of units backordered during an inventory cycle, we will have this expression. Instead of the summation, we have an integral, and instead of the probabilities, here we have the GDL of x as the density function for the continuous lead time demand, DL. And of course, we'll take the integral for all our OP values, for all x's that are greater than our OP. And then, if we make another assumption saying that the lead time demand or demand during lead time is normally distributed, then this expectation, which is the expected number of units backordered during an inventory cycle, can be written as sigma DL, standard deviation of demand during lead time, multiplied by Gn of z. And what is Gn of z? It is the unit normal loss function. We'll introduce this function later. So this is a known distribution. This is a known function, right? And z here is a normalized random variable, which is equal to ROP minus mu dr divided by sigma dl, sorry. Yeah, and then we can move to the next part in which we calculated the realized fill rate for a given reorder point and order quantity. It is just the same as the this is the same expression that we found. It's the same formula that we found for the discrete distribution case. But here, for the continuous distribution case, under the assumption of normal distribution demand during lead time, this realized fill rate as a function of R, OP, and Q can be expressed as you can see here, right? And again, if Q is sufficiently large, then realized fill rate can be approximated by 1 minus sigma dl Gn of z divided by Q. So here, the second expression in the numerator will be approximated by 0 if Q is sufficiently large. And of course, if we substitute z from the previous slide into this formula, we'll get this expression for the realized fill rate. Again, assume that we have a fill rate, a desired fill rate, right? FR, desired fill rate, not this realized fill rate, which is a function of R, OP, and Q. Assume that we have a desired fill rate, R, and then we have, we know the order quantity Q. Then we need to, find an ROP, which if we put in this formula, then the realized fill rate would be at least equal to the desired fill rate, just similar to what we did for the discrete case. And for the unit loss function Gn of z, we can calculate this function. As you can see here, it is phi of z, the lowercase phi, minus z multiplied by 1 minus capital Phi of z. And here, the lowercase of phi is the probability density function, and phi, the capital 1, is the cumulative distribution function for a standard normal distribution. So we can simply use this expression in, let's say, Excel, for example, to do our calculations for the unit loss function, because probability density function and cumulative distribution function for standard normal distributions are well defined in Excel. So it will make our calculations easy. We'll see some examples in which we'll use these formulas.